Welcome back to another session of The Explainer. Today, we're popping the hood on a truly awe-inspiring topic for this unique micro-explainer, the anatomy of a heavy-duty truck engine. We're going to break down these massive power plants and, more importantly, explore exactly how they are built from the ground up to withstand the immense, literal weight of the global supply chain. It's absolutely fascinating, so let's get right into it. Okay, let's dive into this. Section 1, the anatomy. When you use a word like anatomy for a piece of hardware, you really have to slow down and build some reverence for the sheer scale of the systems that make this machine tick. I want to direct your attention to the exact text right here, the anatomy of a truck engine. Our entire exploration today really hinges on the profound weight of this single phrase, because we aren't just looking at spare parts, we are looking at an intricate ecosystem of heavy-duty components. The absolute foundation is the engine block. It's usually this massive piece of cast iron that houses the cylinders. Sitting right on top of that is the cylinder head, which seals the cylinders and controls the airflow and fuel injection. Inside, you've got your pistons, your connecting rods, and the crankshaft, these heavily machined, constantly moving parts that actually convert combustion into rotational force. It's a wildly complex architecture where thousands of pounds of steel and iron have to work in perfect, continuous harmony. A truck engine. Let's take a heavy pause right here. Just focus your mind entirely on the immense physical reality of this machine for a second. The reason this anatomy has to be so incredibly robust comes down to the sheer physical stress these things endure daily. I mean, a truck engine isn't just casually cruising down the highway, right? It is hauling tens of thousands of pounds up steep mountain grades, generating massive ground-shaking torque. Inside those cylinders, the engine is containing continuous, violent explosions. Dealing with that kind of extreme heat, relentless friction, and immense pressure means the manufacturing tolerances have to be practically flawless. Which brings us to the core mystery of our exploration today. Section 2, the ultimate question. Now, what's really interesting about this slide is how it takes all that mechanical complexity we just talked about and funnels it down into one singular massive inquiry. How is a truck engine made? To build a machine this durable, the process usually starts at a foundry. The main engine block is formed using a process called sand casting, where molten iron, heated to literally thousands of degrees, is poured into a highly precise sand mold. Once that liquid metal cools and hardens, the rough block emerges. But, it's not an engine just yet. It then moves on to precision CNC machining. This is where computer-controlled tools shave away the metal down to the micrometer. That ensures the cylinders are perfectly smooth and the mating surfaces will hold a flawless seal under extreme pressure. Finally, in assembly, all those internal components, the heavy-duty crankshaft, the pistons, the intricate fuel injectors, they're all married to the block by highly trained technicians and robotics. It's a remarkable fusion of raw, heavy industry and microscopic precision. But as we look toward the future, with the sudden rise of electric commercial vehicles and alternative fuels, it leaves us with this profound unanswered thought. Are we currently witnessing the final perfected era of the traditional internal combustion truck engine? Now, that is an incredible evolution to think about. Thanks for joining me on this explainer, and I'll catch you next time.